Constant rate of change. We're going to determine whether the relationship between the two quantities described in the table is linear. If so, we're going to determine the constant rate of change. If it's not, we're going to explain why. So the very first thing is we're going to identify what is our x values, what is our independent values, and what is our dependent values. So the x values are always going to be our independent values. That is going to be our input process. And the y values are going to be our dependent values. That is our output values. So this is the answer when you input this into an equation. So in order to determine if it's going to be a constant rate of change or if it's going to be a linear relationship, we need to determine how are we going from 10 to 18, how are we going from 18 to 24, and how are we going from 24 to 28. And then we're going to determine the same thing for the x values. So to go from 10 to 18 is a positive increase of 8. To go to 18 to 24 is a positive increase of 6. To go from 24 to 28 is a positive increase of 4. Now, to go from 1 to 2 is a positive increase of 1. To go from 2 to 3 is a positive increase of 1. To go from 3 to 4 is also a positive increase of 1. So, now to determine if it is a linear relationship, we're going to find the constant rate of change for each one of these and determine if they're the exact same. So, if I do 8 divided by 1, I'm going to get 8. If I do 6 divided by 1, I'm going to get 6. And if I do 4 divided by 1, I'm going to get 4. Because each one of these answer choices is different, there's no constant rate of change. Therefore, it is not a linear relationship. And that's all we do.